Second is just capillary beds. I want you to kind of appreciate how we regulate blood flow through capillary beds. We're going to get back to this concept as we move into next term because the kidney, really complex organ, but it's basically a bunch of capillary beds. So if you know how capillary beds work in a normal situation, it makes learning about that system quite a bit easier. But basically, you've got an arteriole, which was our smallest of the arteries, and you've got a venule, which is the smallest of the veins. They're connected usually by a single capillary bed, sometimes two, and that was called a portal system. We mentioned that briefly with the endocrine system. But this is a non-active capillary bed. So you have blood moving through here, but it's not being allowed to move into the distal regions of the capillary bed because this tissue will assume is not active. You're not doing anything. So these are your calves right now. This is most of your body right now, not your brains. Most of your body. Now, when anything becomes active near this capillary bed, you have an increase in CO2 production, a decrease in oxygen, increase in waste products. All of those things that are associated with activity dilate what are called the precapillary sphincters. And then you get this. So with dilating those sphincters, you allow blood to go throughout the entire capillary bed, and you hopefully get rid of all those waste products and bring in new ones. And so that's a basic way that a capillary bed works. This is why keeping yourself active is a really good way to lower blood pressure and improve circulation. Because if you just sit here and you don't eat and you just sit, you don't do anything, most of the capillary beds in your body constrict. And so you actually have a much smaller volume for your blood and your blood pressure tends to rise. One of the easiest ways to lower blood pressure is simply by dilating some capillary beds. And so that's like a really nerdy way to say what you're doing when you go for a run or something. You go dilate, like the health aspect of it, I'm going to go dilate some capillary beds real quick. But it does, it lowers your blood pressure for about 2 to 3 hours. And it's just simply because you're creating more space for your blood to exist in, so the pressure tends to come down. And you can't do it too much. You can only perfuse about 1/3 of your capillary beds at one time. This is why this is an issue in certain sports that require full body activity. You can't really do, like wrestling is the hardest thing ever in terms of blood flow management because you're requesting blood to basically all the muscles in your body now and maximum. And this is where you'll get puking sometimes because if your stomach doesn't get enough blood, you tend to puke. And so it's one of the issues you play when you have a sport that requires your entire body. Something like wrestling or maybe MMA or something like that. All right, so that's it for capillary beds. Let me give you a few pointers about arteries before I let you guys move on with those. So we got a lot of arteries here. Take a look at the arterial system as a whole. I'll point out a couple specific names just to give you examples of how we name them, because knowing how the naming system works really helps. In this case, like knowing when you hear common, what does that mean? And I'll get to that in a second, but just look at the whole system. The reason the arterial system is a little easier is it's less variable. Most of us in the room have about 95% of the same arterial system. There's variation in their arterial system like any system, but it's less common than in the venous system. So you're always going to learn more precise information about arteries compared to veins, because veins, if you just look at the inside of your elbows and compare them to someone else, they're likely to be different. But if we looked at the arterial blood flow through your arm, through all of our arms, they would be remarkably similar. Way less variation, and arteries are much deeper. Arteries have such a high value in terms of if you cut an artery, you're going to bleed really quickly. Hopefully none of us in this room have ever lacerated an artery. It is a hugely acute event because of how much blood flow can come out of, let's say, your brachial artery up here. And so we hide those arteries deep along bones, making it really hard to break them, except for when you fracture bones. So fracturing bones, that's probably your biggest risk immediately, is that you could have broken the brachial artery if you fracture your humerus. Now this is rare because fracturing your humerus usually happens people that are very active or driving cars, stuff like that. And those people tend to have more elastic arteries so they can actually withstand a lot of pull. Older individuals are the only ones that occasionally upon falling can actually almost shatter their arteries because they're so hard at that point. but it's much more common actually in younger individuals. But notice the name, brachial artery. Why do we think we call it that? Because it's in the brachial region of the body, right? Real easy. Let's see, it's an artery on the outside of the arm. Well, it's kind of right over the radius. Let's call it the radial artery. This one's over the ulna. Let's call it the ulnar artery. So it really is quite simple. You could guess a lot of these names. So don't be too intimidated by how many you see here. For the most part, also, the arterial tree is symmetrical. The left side of the body and the right side of the body are almost identical. I'll point out the big difference, and that's up in the aorta. So hopefully you guys looked at this when you were studying the heart. It's a little small here, but you guys have seen the aorta, and there are 3 vessels coming off of it. And so if my fingers represent the 3 vessels, in about 85% of people, and this is my heart on me, this first one, if blood's coming this direction, just like it is in the picture, the first one is the brachiocephalic trunk. And just think about what that means. Brachio is referring to brachium, just like brachial artery, and cephalic means head. And so this is a vessel that is going to bring blood to both the arm and the head. That's what that name is kind of telling you. That's the first one, brachiocephalic trunk. And then the second one is going to be the left common carotid artery. And it's left because it's a little hard to see here, but these other two, so this one and this one in my hand, those both actually go to the left side of the body. So that's why it's asymmetrical. You have one brachiocephalic trunk going off to the right side, and then you have the left common carotid and the left subclavian on the left side. And so that's what I mean by asymmetry. Now I say 85% of people because a lot of people actually have, about 15% of people have a different variation of this. Some people have 4, so they actually are symmetrical. Some people have 2, so they are symmetrical, but the normal thing for humans is 3. Brachiocephalic, sorry, it sucks. But brachiocephalic trunk, and there's no left or right. Do not write left or right. Don't put a left or right on it. Because if you do that, that infers that that individual has a right and a left version, which may be the case someday, but it isn't in our standard anatomy and physiology course. So just brachiocephalic trunk, left common carotid, and left subclavian. That's what comes off of there. So make sure you focus on that. The aorta is also what's going to tell you whether or not you're looking at arteries or veins. Right? So if you have a picture, if I give you this in black and white, there's no aorta on the venous side. You have a very different architecture near the heart. So that's what I would encourage you to look at in order to figure out whether or not you're looking at arteries or veins, even without the color. But pay attention to these root words. I encourage you to know what every word means. Subclavian. Clavian is referring to clavicle. So this is an artery that runs below the clavicle. The subclavian turns into the axillary artery in your armpit or your axilla, so that's where it gets its name. Then as it moves along the humerus, it's the brachial artery, because that's the body region. And then we already went over, just find the thumb to know if you're on the radial side. Remember, we rotate, so it gets a little confusing. Find the thumb, always the radius, so that's got to be radial artery, that's got to be ulnar artery, and then you've got some digital arteries, which are just referring to the arteries that go to your finger. And so really not too bad here with this kind of stuff. Yeah?
I'm just looking at the lab manual right now, and it has a right and left subclavian, and then common carotid that are going middle. Is that?
There's still left and right common carotid. Let me continue on from brachiocephalic to see if it answers your question. So, brachiocephalic trunk, that first branch off of the aorta, it immediately splits. Like it's a very short segment just right here. It immediately splits into the right common carotid and the right subclavian. Because arteries and veins are named by their branching patterns. They get one name, and then once they split, they get a different name. That's how we name them. It's not exactly how we name roads, so it's somewhat unfamiliar, but it actually makes some sense. When you hear the term common, like common carotid, that is indicating that very soon it's going to split into 2 vessels that share the same name. Let me give you an example. Common carotid arteries, this would be the right side, it splits into an external carotid and an internal carotid. So anytime you hear that word common, you know if you follow the trail, it's going to split into something with a very similar name. Let me give you one more example down here. Common iliac artery, it's right near the ilium, look at that, and in the iliac region. And it's going to split into an external iliac artery and an internal iliac artery going back into your butt. It goes into the screen, kind of. So that's why these aren't so bad. They're not totally random terms. As long as you remember some of the body regions, they should be pretty easy to remember. And again, for veins, take a look at veins, and right now they probably look pretty similar. But once you get a good look at the arteries, by the time next week rolls along, I think you'll look at that and say, oh, that's clearly the veins, clearly. There's a lot more of them in your arms. You don't have any of the same thing going on in the heart. So again, we're going to save that until next week. So let me point you guys into activities that I think are fun.